Hi everyone. We're looking at a constant acceleration problem here from mechanics. Let's go through the question quickly. The question reads, the displacement time graph below shows the motion of an object fired vertically upwards with speed 24.5 meters per second from the edge of a cliff. The object travels in a vertical line and hits the ground below at x equals 0. Once we know this line, this line should be x. Here is represented by the time t, because we are looking at a displacement time graph. We have the distance here and time, displacement time graph. Now, this graph is given to us from the initial point up to this position here. The displacement is 29.4 meters. And from here, initial point to here, we don't know. It's represented by r. This is x distance. This distance is x, but it's represented by time. So we are given that x to know. This is x-axis. And now we are asked to find the value of p. We are asked to find the value of q. And we are asked to find the value of r. So how do we go about this problem? Now, what we see here, PQ, this is time. What we see here, R, this is distance, S. You know, when you are solving these problems, S is distance. We know that. So let's see what we have. We are given the speed. Because this firing of the object starts from this point, so its speed here should be the initial speed, which is 24.5 meters per second. So initial speed, which is u, is equals 24.5 meters per second. And what is the final speed? Find the value of p. So they want us to calculate the final speed here, the final speed here. What will be the final speed at this point? The final speed at this point should be 0. Why? Because this is the maximum turning point of the graph. Normally we say the vertex of the graph, the maximum turning point. The velocity here, the maximum velocity is 0. It's the stopping point, because when the particle goes to that point, before it starts to descend, there will be a 0 velocity here momentarily before it starts to descend. So therefore the maximum velocity we have there, which is 0, and v equals 0. And then time, that is what we are asked to find. This p here is the time at the maximum velocity. So time, we don't know, which is p in this case. We represent time by p. What other information do we need? We need the acceleration due to gravity. This object is fired vertically upwards. So we take upward motion to be positive. And therefore acceleration due to gravity on that particle is going to be A is going to be minus 9.8 meters per second square. Some books, they give this minus 10 meters per second square. Some they say 8 meters per second square. So according to our 5 formulas we have for constant acceleration, which one should we use here? We are given u, v, t, a. So obviously it's the first formula, which says final velocity is equals to initial velocity plus acceleration times the time. This is what we use. So final velocity we know is 0 is equals to initial velocity, which is 24.5, and plus A, which is minus 9.8, so you put the minus 9.8 times the time. Our time here is P. I have to find P, represented by time. So this is what we have. So it's like 0 equals 24.5 minus 9.8p. Now we want to make p the subject of the formula, so we take it on the other side of the equality sign. Now the minus will become plus here, so it's going to be now plus 9.8p equals 24.5. Divide throughout by 9.8 to get p. So if you divide 9.8, also divide here by 9.8, so this cancels. It's going to be p equals 24.5 over 9.8. Let's use our calculator. 24.5 divided by 9.8. It's 2.5 seconds. So our answer is 2.5 seconds. That is the value of P. Now let's find the value of Q. So this is gone. Now we need Q. Again, let's see what we have. Q is also time. It's also time we need. But P is different from Q. P, the time at which the object was at its maximum point. And Q now is the time at which the object is at its lowest point. That is on the ground level. Right? So, what have we got? Here, we need to consider the total distance the object has traveled to reach here. But this object was projected or fired from a position of 29.4 meters from the ground. So therefore, we have our distance. Instead of positive, because it didn't start from the bottom here, it starts from here. So we have to compensate for this distance. So it's going to be minus 29.4 meters. And initial velocity, u, we are given 24.5 meters per second. And acceleration, got to know, is there any object that is fired upwards or thrown downwards, it has an acceleration due to gravity. You should know that. Whether it's given to you or not. That's why the acceleration due to gravity is a constant, 9.8 meters per second squared or 10 meters per second squared. So we'll have it here again as minus 9.8 meters per second squared. We're asked to find Q. So this Q, that is the time. Time now, we represent it again by Q. So we have this information here. What formula do we use? So you can see S equals UT plus half AT squared. This is the most appropriate formula to use with this information we have. We got the U, we got the S, we got the T. T is not given. T is what we are going to find Q. We got the A. So now let's transform it into this Q, which means now it's going to be S equals UQ, because T is Q, what you are trying to find, plus half AQ squared. We are looking for this Q time. So S, we know it to be minus 29.4, and U is 24.5, 24.5, Q unknown. We are looking to find the value of half A, acceleration due to gravity, minus 9.8, and Q squared. We are trying to find that one. Let's simplify. We have minus 29.4 equals 24.5 Q plus, simplify this, so this minus will come out of the brackets, which will now be minus here, not plus again. 9.8 divided by 2 is 4.9 minus 4.9 q squared. So what do you see here? This is obviously a quadratic equation. Q squared, the power of 2 here is a polynomial. Highest power of q is 2, so it's a quadratic equation. So we divide throughout by
Mommy.
we divide throughout by 4.9, so that we can get q squared here. If we divide throughout by 4.9, this is definitely going to be now q squared minus 24.5 divided by 4.9. You get here 5q. This is equals to 29.4 divided by 4.9. This is equals to minus 6. Fine. Got all integers now. Let's make it look good. We don't want this q to have a positive number. We want to give it a negative. To have a negative number. We want to give it a positive number. So we'll bring everything over the equality sign and leave 0 here. So this is now going to be q squared. This goes over the equality sign. It's going to change sign to minus 5q. This still remains there. Going to be minus 6 equals what is left now is 0. So now we factorize. We know the methods of factorization. We have plenty of them. We've done them before. We started with quadratic equations, so we know how to factorize this. You just find numbers, two numbers that you add together, you get minus 5. But when you multiply them, the same numbers together, you get minus 6. What are those two numbers? So you look at 5. What number would you add to get minus 5? Or the same numbers when you multiply, you get minus 6. This is just to. So you come to look at the factors of 6. Now minus 6. And having in mind you have minus 5 here. Let's not just waste time. You know, minus 6 plus 1 will give you 5. 6, 1 minus 6 is minus 5. So these are the factors you need, 6 and 1. So therefore, q squared minus 6q plus q minus 6 equals 0. I've split this 5 to the factors of minus 6. So now we get q into q minus 6 plus q minus 6 equals 0. So it means, sorry, that should be, yeah, q minus 6, q minus, yeah, that's correct. I need space somewhere. I want to get rid of this. We'll finish this side. Yeah? So now we'll factorize this one. You get q plus 1. You will have now q minus 6 and q plus 1 equals 0. This is what you get. Q minus 6 and q plus 1 equals 0. And which means q equals 6 or q equals minus 1. But time cannot be minus 1. Minus 1. It's got to be positive. So therefore, Q is equals to 6 seconds. This is done. Now let's go to this, to the last one. Last one. And see where it takes us. Okay. They say find R. You want to find this distance. So in finding this distance R, we're going to look at the entire picture of the diagram or the graph we are given. We now know that the distance S is equals to minus 29.4 meters, because this was not projected from the ground level, it was at a height. So that height, you always got to take it to be negative when the object is projected up and lands on the ground. So we know the initial velocity u is equals to 24.5 meters. And final velocity is 0. And acceleration due to gravity is minus 9.8 meters per second squared. What is R? What is R? R doesn't seem to appear here. We know R is going to be this distance here, which is 24.29.4 plus, it's going to be this distance here from here to here, then plus this distance from here to here. Distance from here to here. So let's call that distance S1. S1. That will give us R. We know from here to here is 29.4, but from here to here, what is it? We don't know. Because from here, graph projectile comes here. We don't know what this R is. So for us to get R, we need to add this distance, 29.4 plus this one here. That will give us R. So we are looking at distances. We are not looking at time in this case, because now we are looking at distances. So what formula do we use? We use V squared equals U squared plus 2AS. That's the other formula this time. Use it this time. V squared, we know it to be 0. U squared, 24.5 plus 2 times acceleration due to gravity, 9.8 S. This is what we are looking at. We are looking for. So this is going to be 24.5 squared plus. Now this is minus sign comes out, so this is going to be minus 2 times 8, 16, carry 1, 2 times 9, 18, plus 1 you carry, 19.6 S. we want S. Bring it over here, so it's going to be positive now. So it's going to be 19.6 S equals 24.5 squared. This number is squared. So S therefore is equals to 24.5 squared all over 19.6. So we use our calculator. Twenty-four point five squared. Which is 600.25 all over 19.6 divided by 19.6. Which is 30.625. That is S. And so therefore R is now 29.4 plus 30.625 in meters. So if you add the two, 29.4 plus 30.625. Come on. This gives you 60.025 meters, and that is the value of R. Thank you for watching.